Here we have another polynomial, which is y equals to minus x cubed plus x squared plus 2x plus 1. Now, here also we'll start by finding out the first difference. How do we find out the first difference? We are going to say 1 minus 9, that comes out to be minus 8. Then 1 minus 1, which comes out to be 0. Then 3 minus 1 comes out to be 2. 1 minus 3 comes out to be negative 2. Negative 11 minus 1 comes out to be negative 12. And negative 39 minus negative 11 comes out to be minus 28. Similarly, we'll find the second difference. And for the second difference, what we'll do is this time let's take another color. So this time it's going to be 0 minus negative 8, which comes out to be plus 8. Then 2 minus 0, which comes out to be 2. Negative 2 minus 2, that comes out to be minus 4. Negative 12 minus negative 2, that comes out to be minus 10. And negative 28 minus negative 12, which comes out to be negative 16. Okay, so this is how we find the second difference. Now still, if we look at the second difference, these values are not the same, so we have to continue the process, take it over to the next step. And this time it's 2 minus 8 coming out to be negative 6. Negative 4 minus 2 coming out to be negative 6 again. Negative 10 minus negative 4 comes out to be negative 6. And negative 16 minus negative 10, that also comes out to be negative 6. So here we have achieved our goal. So what was the goal that we had to achieve? That all these terms had to be the same. So everywhere the third difference has come out to be negative 6. Okay, so what can we say? Now, what is the degree of this polynomial? Now the polynomial has a degree of 3. And what is the sign of the leading coefficient? The leading coefficient has a sign of minus. So that is a negative sign, or it is actually minus 1. Leading coefficient is minus 1. And the third difference is minus 6. So both of these have the same sign. Okay, so let's see. Again, we have an observation. This is a third degree polynomial and its third difference is constant. The third difference has the same sign as the leading coefficient. Okay, pause the video and try to find out for the following equation what will be the differences, the first difference, second difference, and so on and so forth till you get a constant difference. So the first question has an answer of first difference is constant and the value is going to be 3. And for the second question, the third difference is going to be constant and its value is going to be minus 30. Okay, so just check your answers. So here again we observe that, okay, for the first one, what was the degree of the polynomial? The degree of the polynomial is 1. And since the degree is 1, the first difference here is going to be constant. For this polynomial, what is the degree? The degree is 3, and so the third difference comes out to be constant. Now, what is the sign of the leading term? Here it is positive. This is positive 3. So we just observe that this is positive, and here also the value of the first difference comes out to be positive 3. For this one, what is the value? Here we have a negative sign. So the value of the third difference also has a negative sign to it. Okay. Let us summarize our observation for all these polynomials. For the first polynomial, y equal to x squared plus 2x plus 1, what we observed was that its degree was 2. then its leading coefficient is 1, and the finite difference which came out to be constant was the second finite difference, and the value of the finite difference was 2. Now if we try to calculate the value of an times n factorial, we will get a value of 1. What is an? An is 1 times 2 factorial. Okay. Why 2 factorial? Because the degree is 2. Okay. So 1 times 2 factorial. So what is the value of 1 times 2 factorial? It is 1 into 2, which is equal to 2. Okay. For the next polynomial, y equals to minus x cubed plus x squared plus 2x plus 1, we had observed that the degree was 3, and so was the finite difference, which was constant. It was the third one which was constant. Then the value of the leading coefficient was minus 1, and the value of the finite difference was minus 6. Now if here for this particular equation, if we try to calculate an times n factorial, it will come out to be, what is an? An over here is minus 1, and this times what is the degree of the polynomial is 3. So we'll have 3 factorial. Okay, so what is 3 factorial? 3 factorial means 3 into 2 into 1, and it comes out to be 6. So minus 1 times 6 is minus 6. Okay, for the next equation, y equals to 3x plus 2. What is the degree? The degree is 1. What is the leading coefficient? The leading coefficient is 3. Which finite difference is constant? It is the first finite difference that's constant. And what is the value of the finite difference? It is 3. So let us just calculate an times n factorial. So what is an? An is 3 and times degree is 1, so it is going to be 1 factorial. So 1 factorial is equal to 1. So 3 into 1 equals to 3. So this is what we get. For the next polynomial, we have the leading coefficient as minus 5, the degree as 3, and if we try to find out the value of finite difference, it will come out to be minus 5. It will come out to be minus 5 because minus 5 is the leading coefficient times then 3 factorial because the degree is 3. So what we get is going to be, what is 3 factorial? 3 factorial is 3 into 3 times 2 times 1. So it comes out to be 6. So minus 5 times 6, which is minus 30. Okay. If we have an nth degree polynomial where n is greater than 0, that means it should not be a constant term. So we are not talking about y is equal to 3 or y is equal to 5. We are talking about the polynomials which have at least a degree of 1. Okay, so if we have a degree n polynomial, then what things would be valid? First, its nth difference will be constant. If it's an nth degree polynomial, then its nth difference is constant. If it's a first degree polynomial, then the first difference will be constant. If it's a second degree polynomial, if it's a quadratic expression, in that case, its second difference will be constant. Then what is the value of the nth difference? Now, the formula for the value of the nth difference is an times n factorial. What is an over here? This an is going to be the leading coefficient. And what is n? N is the degree of the polynomial. So if you find out the value of an times n factorial, that would be the value of the nth difference, which is constant. Then we come to the next thing. The sign of the nth difference will be same as the sign of the leading coefficient. Now, if you can see over here, what is n factorial? This n factorial, the value of n factorial, this is always going to be positive. So what is going to determine the value of the nth difference? The sign of the nth difference, it is the sign of this particular term, that is an. Okay, that is the leading coefficient.